Okay, so let us now finish our discussion on mechanics. So this will be lesson 18 with power. So we've spoken about what is it? We've spoken about forces, we've spoken about work. This section will definitely be much easier to understand if you've been following through with our lessons on all of those topics. So our learning objectives is that at least you should be able to define power as the rate at which work is done or energy is expended. So that is the rate at which energy is transferred. So the rate, remember that rate at which, let me just highlight the entire thing actually. So you need to be able to define that and also put it in symbols where you say P is equals to the work done divided by the change in time. Remember, work is measured in watts, and then any work, no, power is measured in watts, and then work is measured in joules, and then the change in time would then be measured in seconds. So also you should be able to perform calculations where power is involved, or when calculations where with power when work is done. And then also another equation that is important, you should be able to use this equation here where it says the average power is equals to the product of force multiplied by the average velocity when an object moves at a constant speed along a rough horizontal surface or a rough inclined plane. So that is something that you should also be able to do. And then you also have to be able to calculate power output for a pump lifting a mass, e.g. lifting water through a height at a constant speed. So we're going to do a couple of questions, and then you guys also have to be practicing at home using other various questions. So without wasting any time, let us just get straight into that. We have two questions in front of us that we're going to be looking at. Let us read through the first question. It says that calculate the power expended by an engine when an object of mass 10 kg, so we want to calculate the power, is lifted. It's lifted from one point to another to a height of 2.2, I'm a bit tired now, 2.2 meters in a time of 3 seconds at a constant velocity. Okay, so now let us actually try to answer this question. So to answer this question, I always say first start with perhaps a diagram of the situation being described. So you have an object. I'm gonna represent that object with a thingy, a box, and we're trying to move it from this so let's call this initial height to a certain height here, yf. So you're trying to get this object to move from here up until there, and then that change in y, which is yf minus yi, is equals to 2,2 meters. So what did they say? I'm trying to read this question again. So power expended an engine. So we have a force of an engine doing work. So let us draw a free body diagram of this. So we have a force of an engine in this direction because it's pushing this thing up. So let's call this F engine. And then we also know because it's moving up, it will also be subject to Fg gravity, the force of gravity. And they said that this thing is actually moving at a constant speed or velocity. So this means that we have to actually apply Newton's first law of motion where we say F net equals to 0. It's 0 because remember for Newton's second law, F net is equals to the product of mass and acceleration. And if something is moving at a constant speed or a constant velocity, its acceleration is 0. So we now have to look at our forces. We have a F engine. So let us say up is a positive and then down is negative. So we have F engine plus F net minus F gravity or weight. Gravity is equals to 0. So I can just write this F as F engine will then be equals to F gravity. but we know that F gravity is actually given by mg, right? So that's one thing that is important to know. And then we know that our equation for work is actually P equals to work, the rate at which work is done. And then work, we know it's given by the product of the force. So the force that is doing work there is the engine, and then multiplied by the change in y, because it's moving up, it's not moving to horizontally, multiplied by the cosine of theta, where theta is the angle between motion as well as the force that is doing work, which is that force of the engine, divided by the change in t. So now we said F engine is mg multiplied by a change in y, multiplied by a change in y, multiplied by the cosine of theta, divided by a change in t. So it's now just a matter of substituting everything that you know. We know the mass of this to be 100. We know g is 9.8. So we don't concern ourselves with direction, because power again is a scalar quantity, multiplied by the cos of, so that angle. So your object is moving up, right? It's going up, and as well as the force of the engine is also going up, like we drew it here. Where is it? We draw it here. They are both in the same direction. The angle between them is 0. So meaning that theta here will actually be 0. So 0, and then this entire thing divided by 3. So if you do this, I think you're supposed to come, I forgot something, didn't I? Don't make this mistake. So multiplied by the change in y is 2.2, multiplied by the cosine of the angle 0. So please don't make that mistake, and I seem to always forget it. So please, it's important to not make that mistake, otherwise you're gonna get a wrong answer. And then if you put this in your calculator, try to see if you'll also find a value of 718.67 watts, right? So I think we've answered that question. Let us now go to the second question. The second question said to us, a man. So we have a man who lifts a 50 kg bag of cement. So mass is 50 kg with a rope from the ground level to a height of about 4 meters above ground, and in such a way that the bag of cement moves at a constant velocity. Determine his average power if he does this in 10 seconds. All right, cool. So it's almost the same dance that we did previously. I'll just put that away and wipe this. So it's almost going to be similar. There's not going to be... So remember, now you were introduced to the equation for average power, and it goes something like P AVG equals to F, or that's product. I'm not sure if that was on the screen. AVG multiplied, I'm lying, F, product of that force, and average velocity, AVG, right? Yes. I wrote age here. So this is AVG. Okay, cool. And then we can actually write this as F equals to the average, a change in X, but because we're moving up, it's going to be a change in Y, a change in Y over a change in T. I think my markers are just running out now. Change in Y, change in T. But now let us also again draw the situation that was described to us. We had a block that was lifted with a rope, right? And it's going in that direction. So it's moving from yi, from this position, to yf, and then that change in y is given by yf minus yi, and they said it's approximately 4 meters, correct? And then we can also draw a free body diagram. So because it's been pulled with a string, it's been lifted with a string, we know that we'll have tension, and then we will have Fg here. And then we can say up is positive and then down is negative. So we apply the same thing. If it's moving at a constant speed, it means F net equals to 0. This means that Ft plus minus Fg will equals to 0. So this means that Fg is the force of gravity, Ft is the force, is the tension, will be equals to Fg, which is equals to mg, right? More or less the same thing that we did a bit earlier. And then we can take our equation that we wrote there and say P average then will be equals to F, a change in Y over a change in T, meaning it will be F, we said it's given by mg, a change in Y over a change in T. Okay, cool. So now we seem to have everything that we need. We have the mass. They said the mass is, how much is that? I think it is 10. What is that question? Multiplied. So we have 10. It's 10 multiplied by 9.8 multiplied by a change in y. It moves a value of 4. All of it, but they say that this whole thing takes about 10 seconds. And then it's just a matter of putting this in your calculator, and I think you will come up to a value of 160 watts. So that is the average power. And yes, this actually brings us to the end of this lesson. Like I mentioned, it wasn't going to be a long lesson or a difficult one because you've already been introduced to concepts of force, work done, energy, and everything else. And yeah, this wraps our discussion on work, energy, and power, as well as our discussion on mechanics. Remember, mechanics in your paper, you're going to be writing out of 150 for paper 1, and 65 marks of those marks is actually on mechanics. So it's very important for you to practice mechanics so that we can actually get those good marks. Again, thank you so much for watching.